Okay, I ran out of time on the last video, and so I hadn't quite finished discussing the periodic table, so I want to say a few more things about it. But just a reminder, each tall column, okay, you can predict easily the number of valence electrons in the elements in those columns. Column 1, or sometimes referred to as column 1A, okay, all of those elements are going to have one valence electron. Column 2, everything's going to have two valence electrons. These short columns, those are the ones that, remember, they don't have any simple rules. That's more complicated chemistry than we're going to get into in 8th grade. So we're pretty much not going to deal with these guys as far as trying to figure out their valence electrons. And then we are back to tall columns over here. This is column 13 or column 3A. Okay, right there. And everything in that column has 3 valence electrons. Everything in this column has 4 valence electrons. Everything in this column has 5 valence electrons. Everything in this column 6, everything in this column 7, and everything in this column has 8 valence electrons except for helium. And the reason why helium is over here, even though it only has 2 valence electrons, is because helium has a filled outer energy level. It only uses the first energy level, and you know that it's filled with just 2 electrons. So it's got a full outer energy level, and so it's not going to form any bonds because it's already got all the electrons that it needs for that full energy level. And that's the case with neon, argon, krypton, xenon, and radon. They all have 8 electrons in their outermost energy level. That is a happy number, and so they're not going to roam around looking for anything to react with either. It's called because they're all very unreactive because they all have a filled outer shell of electrons. Okay? All right, I think we will, but just to double check. How many valence electrons does nitrogen and phosphorus have? Okay, nitrogen and phosphorus are both in the same column. And remember that everything in the same column has the same number of valence electrons. So they are in column 15, or 15 is otherwise known as column 5A. Okay, so they both have 5 valence electrons, so 5 and 5. Okay, elements in the same column have those similar chemical properties because they have the same number of valence electrons. That's really important. Okay. And one other thing in the last screencast that I forgot to have you underline and mention, I think I said it, but I don't think I had you guys underline it, is elements in the same group or vertical column have the same number of valence electrons. So make sure you underline that. That's really important. And we've said that several times now. Okay, now we're going to turn the page and go to page 143 and discuss the important points on this page. It says, why do atoms form bonds? Well, an atom tends to form bonds if its outermost energy level is not full. Okay. So, unless it's helium, atoms that have fewer than 8 valence electrons are not going to have a full outermost energy level. And in order for them to get an outermost energy level that is full, they're either going to gain or lose or share valence electrons to form bonds. That's what chemistry is all about. It's gaining, losing, or sharing valence electrons to form compounds where you have atoms that have a stable outer shell of electrons. Okay? When atoms form bonds, their outermost energy levels may be filled. For example, a chlorine atom has 7 valence electrons, and 1 more would fill its outermost energy level. A chlorine atom can gain 1 electron from a sodium atom. It's a perfect match. When this happens, the chlorine atom has 1 more negatively charged electron than it has positively charged protons. Okay? The atom becomes a negative ion. If it's going to gain, okay, if it gains negatively charged electrons, then it becomes a negative ion. because it's gaining negative charges. If it loses negatively charged electrons, then now it has more protons than electrons, and it becomes a positively charged ion. Okay? An ion is a charged particle that forms when a neutral atom gains or loses an electron. Okay? Sodium loses an electron and becomes a positive ion. And remember that chlorine gains that electron and becomes a negative ion. Okay? When that happens, they both have full outer shells of electrons, and so they form a powerful bond, and that is known as table salt, sodium chloride. Okay, let me show you real briefly what I'm talking about. We just talked about sodium and chlorine forming a bond, and this diagram kind of helps you visualize what's going on. Sodium has a total of 11 electrons when it starts out as a neutral atom, because it has 11 protons, 12 neutrons, and 11 electrons. Chlorine has 17 protons, 18 neutrons, and 17 electrons when it's a neutral atom. And if you look up here, you notice that sodium only has one valence electron, and that chlorine has 7 valence electrons. Okay, what's going to happen is sodium is going to give up its one valence electron, and it's going to be transferred to chlorine. When that happens, sodium drops down and now only has 2 energy levels, which are both full. And also, when that electron is transferred, chlorine now has gained the final electron that it needs to have a full outer shell of electrons. Okay? So when that electron is transferred, sodium loses a negative and becomes a positive ion, and chlorine gains an extra negative charge and becomes a negative ion. Sodium is now positively charged, chlorine is now negatively charged, opposites attract, and that's how the bond is maintained. Okay, so to go back to this page so that we can finish up. It says in the space below each Bohr model, write the number of valence electrons that each atom has. Hydrogen, you'll see, only has 1 valence electron. Neon has 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. Sodium, as we just saw, only has 1 valence electron. Helium has 2. Carbon has 1, 2, 3, 4 valence electrons. And chlorine has 7 valence electrons. All right, it says circle the atoms that are likely to form chemical bonds with other atoms. Okay. I'm going to circle hydrogen because it only has 1 valence electron and it would need 2 to have a full outer shell, so it's going to form a bond. Neon is not going to form any bonds because it already has a full outer shell of electrons at 8. Sodium will form a bond, like we saw just a minute ago, because it only has 1 valence electron and it needs 8 to be stable. Helium has 2 valence electrons in its outermost energy level, so it's stable. It's not going to form any bonds. Carbon has 1, 2, 3, 4, but it needs 8 to be stable and have a full outer shell of electrons, so carbon will form chemical bonds. And chlorine has 1, 2, 3, 4, 5, 6, 7, but it needs 8, so it will also form chemical bonds. Okay. All right. And then just to wrap it up, on the back, it says a chemical bond is an interaction that holds 2 atoms together. Atoms are rearranged during a chemical change when bonds break and form. That is true. A Bohr model shows the number of electrons in each energy level of an atom. Okay. A Bohr model is the best choice to show how atoms are arranged in molecules. That is false. Okay. If we want to know how they're arranged as molecules, we probably want to use that space-filling model that we looked at. And then valence electrons are the electrons in an outermost energy level of an atom. The atom Above is reactive because its outermost energy level is not full. That is true. Okay. And then to answer question number 21, which is down here, it says, why are atoms of lithium, sodium, and potassium almost never found alone in nature? Well, here's lithium, here's sodium, and here's potassium. They all have one valence electron, and they're all very, very reactive because they're going to give up that one valence electron and form a compound with somebody. So they are found... Okay, so these three are going to easily give up their one valence electron and form compounds. That's why you don't find them alone in nature. They're too reactive. They will form compounds with something. So you're not going to walk around and just find a chunk of lithium or sodium or potassium or anything like that.